Okay. Yesterday we started solving another problem. Find the trigonometric Fourier series for the continuous time periodic signal. Okay. This is a half-wave rectifier output. So we are applying sinusoidal signal to the half-wave rectifier. The output of the half-wave rectifier, depending on the circuit diagram, either positive portion of your input will be clipped or negative portion of the input will be clipped. So here we are getting only positive input, negative inputs are skipped. Okay. So this signal will be available in the question paper, or they will ask draw the signal sketch for the half-wave rectifier output and find the trigonometric Fourier series for that particular signal. Okay. Anyway, you have to be ready. Either you have to draw the signal or the signal will be available. So total time period. So this complete set follows one time period and omega naught. Then general formula for sinusoidal signal A sin omega naught t, A cos omega naught t, like that. So yesterday we have derived A naught and AN value. So let's check for BN formula. BN equal to general formula 2 divided by fundamental time period, integration over the time period, x of t sin n omega naught t into dt. So this is general formula. So in this example, what is omega naught value? Omega naught value 1. So total time period 2 pi. 2 pi integration 0 to pi only signal available. Okay. A sin omega naught t t. So this is sin nt. Omega naught value 1. Correct. So A sin t sin nt dt 0 to pi. So solve this integration. Sin A sin B formula. To solve this integration limit, first expand this sin A and sin B formula. So sin A sin B equal to 1 by 2 cos A minus B minus cos A plus B. Okay. So this 2 will be cancelled. Now according to this formula, we are getting 1 by 2 pi. A is a constant, so take outside. So integration 0 to pi cos A minus B. Cos 1 minus nt minus cos 1 plus nt dt. So integration of cos theta sin theta, then apply the limit 0 to pi. A divided by 2 pi sine of 1 minus nt divided by 1 minus n. Substitute the limit 0 to pi. Minus cos sine of 1 plus nt divided by 1 plus n. 0 to pi. Okay. So sine pi, sine 0, your result will be 0 only. So 0 dot 0 minus 0 and 0 dot anything 0. So your Bn value is 0. You substitute your upper limit and lower limit. Sine pi also 0, sine 0 also 0. Or sine n pi 0. So for this example, Bn equal to 0. Okay. So A naught An value calculated and Bn value 0. In some reference book, they follows A1, B1 also separately. Apart from A naught, An, Bn general, they try to calculate A1 separately and B1 separately. Okay. So A1 meaning in AN formula, we have to substitute n equal to 1. Otherwise, for n equal to 1, sorry, for n equal to 1, what is the AN equation? For n equal to 1, what is the BN equations? Or you can stop A naught, AN, BN. That is also sufficient. But for this example particularly, BN value is 0, but for n equal to 1, we will get some expression for BN. Okay. So AN value now 2 divided by 2 pi, 0 to pi, A sin t cos n omega naught, n value 1. So cos t dt. Okay. So like this. Cos n omega naught t, n value you have to substitute 1. So expand this. This is just for hint for you. Apart from A naught, A and B n, you try to calculate n equal to 1 for A n and n equal to 1 for B n. So if you expand sin A cos B and substitute all the value, I think you will get 0 for this. So please verify. For Bn value, you will get 2 divided by 2 pi integration 0 to pi A sin t x of t sin n t, n value 1 sin t dot t. So A divided by pi integration 0 to pi sin square t into dt. So A divided by pi 1 minus cos 2t, right? 1 minus sin square theta equal to 1 minus cos 2 theta by 2. So that 2 you taken outside. 0 to pi into dt. Okay. So for B1 nearly you will get A by 2. Okay. So this is optional only. Apart from A naught, A and Bn, you try to calculate n equal to 1, what is Bn value? N equal to 1, what is An value? Okay. So once you find A naught, A and Bn value, write down your trigonometric Fourier series expressions. What is trigonometric Fourier series expression? Any continuous time periodic signal can be represented by its harmonics of sinusoidal component and harmonics of its cosine component. So substitute your A naught, A and Bn value in this expression. A naught plus summation An cos n omega naught t, n from 1 to infinite, plus summation Bn sin n omega naught t, n equal to 1 to infinite. Substitute your A naught value, An value, Bn value in the trigonometric Fourier series. Finish. So if you solve A1, B1, then it will be even better. A1, B1. Or else also no problem. Right. So trigonometric Fourier series, I think I have solved 3 problems. A lot of problems are available. I will send you the material. Okay. So now we'll start exponential Fourier series format. Exponential Fourier series. Okay. So this is another form of Fourier series. Any continuous time Fourier series can be represented by exponential Fourier series format. So what is the expression for this? X of t equal to, have you studied this in mathematics? Exponential Fourier series. So x of t equal to summation a k e power j k omega naught t, where k varies from minus infinite to infinite. So this is a representation of a continuous time periodic signal by exponential Fourier series format. Here AK is a Fourier series coefficient. Fourier series coefficient. Okay, AK or Fourier series constant AK. So the formula for AK, 1 by fundamental time period, integration over the time, x of t e power minus jk omega naught t into dt. Okay, exponential Fourier series representation. So read the questions carefully in your examinations, whether they're asking to solve for trigonometric Fourier series or exponential Fourier series. Okay. So previous problems related with trigonometric Fourier series. So this is exponential Fourier series. The basic steps are same. For the given signal, we have to identify the fundamental time period capital T and then omega naught. Then find the value for AK and substitute it. Then exponential Fourier series, and one more possibility is available. Magnitude spectrum and phase spectrum. Draw the magnitude spectrum and phase spectrum. Okay. So after finding AK, your result will be in the form of complex number, A plus JB format. Okay. So magnitude spectrum represent K versus modulus AK. For each and every values of K, root of A square plus B square. To draw the phase spectrum, K versus angle of AK. Substitute K 0, 1, 2, 3, and so on. For each and every values of K, we have to calculate angle of K. So what is the formula for angle of K? Magnitude of a complex number, root of A square plus B square. Angle of a complex number, tan inverse of B by A. So in exponential Fourier series problem, and for some problems, we are going to find out AK and X of t expression in added to that magnitude spectrum for AK and phase spectrum for AK. Okay. So first problem in exponential Fourier series. Find the exponential Fourier series coefficient or exponential Fourier series representation of the given periodic. So the signal sketch given to you 0, 1, 2. Like this. And 3, 4 value 0. Again 4, 5, 6. So 7, 8, 0. And then this repeating. So this side -1, -2, -3, minus. So from -4 and then this is 0, and so on. Magnitude 2, this is magnitude 1. Okay. So this is the signal given in the question. T versus X of t, some signal given. So if you look at this signal, this shape of this signal go like this, correct? This format is repeating over and over. 0 to 1, magnitude 2. 1 to 2, magnitude 1. And 2 to 4, 0. Then again same format will be repeated. Okay. So the time period of the signal starting from here up to 4. Correct? This forms one fundamental time period or one fundamental cycle. Okay. So capital T equal to 4. So omega naught value 2 pi by T. 2 pi by 4. So omega naught equal to pi by 2. Pi by 2 radian per second. Okay. Now directly find out the exponential Fourier series coefficient AK. So what is the formula for AK? 1 divided by fundamental time period over the interval over the fundamental time period x of t e power minus jk omega naught t into dt. So x of t expressions we need to write from the given signal. So directly we can write the x of t expression for this particular signal 0 to 1 magnitude 2, t between 0 to 1, 1 to 2 magnitude 1, 1 to 2 magnitude 1, and 2 to 4 0. Okay, so like this you may consider 4 to 8. Okay, if you consider 4 to 8 information, then your integration limit will be changing 4 to 5, 5 to 6, and 6 to 8 0. You will get the same answer. So x of t 2 for 0 to 1, 1 for 1 to 2, and 2 to 4 nothing. So AK 1 by 4. So how to solve this problem? 0 to 1 plus integration 1 to 2 plus integration 2 to 4 0 for this particular example. So 0 to 1, 1 to 2. So these two interval is valid. So 1 by 4 integration 0 to 1 x of t. X of t magnitude I think 2 for 0 to 1. E power minus jk omega naught t. Omega naught value pi by 2 into dt. Here 1 to 2 magnitude 1. E power minus jk pi by 2 t dot. So integrate and write down the result. So 2 constant e power minus j theta. So e power minus j theta divided by differentiation of this particular term. So minus j k pi by 2. Substitute 0 to 1. Plus e power minus j k pi by 2 t divided by differentiate the exponential term. So e power minus j k pi by 2. 1 to 2. So substitute the limit carefully and solve for final result of AK. 1 by 4 minus jk pi by 2 is commonly available. Shall we take outside of this? 1 divided by minus jk pi by 2. This 2 will go on top. Okay. So 2 e power minus jk pi by 2 t equal to 1 and minus e power 0 1 2 plus here e power minus jk pi by 2, 2. So this 2 will be cancelled. And minus of e power minus jk pi by 2. Okay. Now reduce this expression in one more step. The value for ak equal to 1 by 4. 2 divided by minus j k pi. Sorry. This term is commonly available. Now further try to simplify this. 2 e power minus j, 2 e power minus jk pi by 2 minus 2 plus e power minus jk pi minus e power minus jk pi. Okay. So 1 times 2 times of 2, 1 divided by minus j. So do you remember 1 by minus j equal to j in a complex number? So j divided by 2k pi. Okay. So in this term, 2 e power minus j k pi by 2 e power j k. Okay. 2 e power minus j k pi by 2. Here 1 e power minus j k pi by 2. So the result is e power minus j k pi by 2. Okay. And minus 2 plus e power minus j k pi. So since e power minus j k pi, e power minus j theta equal to cos theta plus j sin theta in general. So cos k pi minus sin k pi. So sin pi is always 0. So cos n pi value minus 1 power n. Cos n pi value minus 1 power n. So your final result for ak, j divided by 2 pi k e power minus j k pi by 2 minus 2 plus minus 1 power n. So this is your ak. Exponential Fourier series coefficient. Right. So once you completed ak value, substitute the ak in the exponential Fourier series representation. Any continuous time periodic signal can be represented by its exponential Fourier series format. Key from minus infinite to infinite, ak e power jk omega naught t. Omega naught here pi by 2t. Okay. So this ak we have to substitute at this. Then the problem is over. So either trigonometric Fourier series or exponential Fourier series. If it is trigonometric Fourier series, it's very simple because only one Fourier series coefficient you are going to find out. Trigonometric Fourier series meaning a naught, a n, b n. 3 we need to find out. Exponential ak only we have to find out. So is it understanding? Similar procedure. Only formula we have to remember, and practice is very important. So only one more problem I'll solve in exponential Fourier series. Second problem. Find exponential Fourier series for the periodic signal shown in figure and plot magnitude and phase response. Find exponential Fourier series. Okay. And plot magnitude response and phase response. So how to find how to draw the magnitude response and phase response, or magnitude spectrum and phase spectrum? Your result AK in the form of complex number, A plus JB form. So we need to substitute K0, 1, 2, 3, K minus 1, minus 2, minus 3, and so on. For each and every values of K, find the magnitude, that is root of A square plus B square. Angle tan inverse of B by A. Then we have to plot the sketch. 0, what is the modulus AK? 1, 2, 3. And here minus 1, minus 2, minus 3. Today, at least, we try to find x of t expression for the given signal. Next class, we will complete this problem. So t versus x of t. From minus 1 to 1, the signal given like this. Magnitude 1. And then, okay, minus 1, 0, 1. So this is 2, 3. This is minus 2, minus 3. Like this. It's a periodic signal. Exists from minus infinite to infinite. Okay. Find the exponential Fourier series coefficient and plot magnitude spectrum, phase spectrum. So what is the time period of the signal? Capital T. Fundamental time period of the signal. You may consider 1 to 3. I'm going to consider this particular portion. One rising, then decreasing. Okay. This portion I'm going to consider. Capital T. Fundamental time period of this. So T equal to 2. Omega naught value formula 2 pi by T. So 2 pi by 2, 2 to cancel, 5 radian per second. Okay. So fundamental time period completed. Omega naught value calculated. Next important thing for this kind of problem, how to write x of t for this signal. Because previous problem available in the form of a constant DC value, a constant value for a particular time period. And the previous problem, sinusoidal for signal. Okay. So first day class, we solved one problem like this. X of t. This kind of signal given, how to find out the x of t expression for each and every time interval, then use this formula. Y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. Here x represent t, y represent your x of t. Okay. Then x1 y1, this point is x1 y1, this point is x2 y2. For this particular signal, minus 1 to 0, minus 1 to 0, your signal goes like this, right? So this is x1 y1 point, this is x2 y2 point. Minus 1 comma 0. Here 0, comma 1. Minus 1 to 0. For 1 to 0, for the time interval 1 to 0, this point consider as x1, y1. And this point consider as x2, y2. So this is 0, comma 1. And this point 1, comma 0. Okay. So for this particular slope, we have to write down one x of t between 0 to 1, and t between minus 1 to 0. Minus 1 to 0, what is the expression? And 0 to 1, what is the expression? Okay. With the help of that formula, y minus y1 by y2 minus y1 equal to x minus x1 divided by x2 minus x1. So using that particular formula, calculate your x of t expression for 1 minus 1 to 0 interval and 0 to 1 interval. Okay. Then we have to use the exponential Fourier series formula, and we have to plot for magnitude spectrum and phase spectrum. So we shall continue this problem in